Today I'm going to be talking about a project research work that we've had going on now for a little bit at the SEI, generally called Acquisition Dynamics. We subtitle it Wargaming for Acquisition because that's essentially what it amounts to. And so with that, let me step right into a description of kind of the original problem we saw that sparked our interest in this work. So let's look at a generic joint program situation. Let's imagine we have a JPO program manager who has, say, 6 stakeholder programs. They're all planning to use the joint infrastructure software being developed by the joint program. Well, the problem is that each of the programs wants to, or demands really, one major feature to be added to the software just for their use. That's not necessarily going to benefit the other stakeholders in the joint program. Well, the JPO program manager may reluctantly agree to do this out of concern of losing the stakeholders who could go off potentially and build their own custom software rather than participating in the joint program solution. But of course, the reason that the PM was reluctant is that the additional design changes and the coding can significantly drive up the total cost, the schedule, the complexity, and the risk that the joint program is facing. As those things go up, you see the schedule start to slip, obviously, and perhaps one program decides to leave the joint program and in fact go off and develop their own custom software. Well, with one stakeholder gone, depending on the funding model, perhaps the amortized costs on the other programs increasing further, and again, the slipping schedules, we see another program or two leaving, and as the costs continue to escalate and the schedules lengthen, we can see participation in the joint program unravel and collapse entirely to the point where maybe you have one program left or even 2 and you hardly even have a joint program. So why is this important? Well, a number of reasons. First of all, we're all aware of a declining defense budget for acquisition. We know that we really need to achieve, perhaps more than ever, the cost savings that have been promised by joint programs. We generally see a higher rate of problems with joint programs, so we know that they're difficult to pull off successfully. And also, the joint program problem is important because it's really kind of a large-scale version of what we see whenever we develop any kind of common infrastructure across programs, even within a single service where we have disparate stakeholder groups, perhaps with different objectives. And we have a growing need for interoperability, and joint programs are a terrific way of achieving interoperability in systems. And software is key to making that interoperability happen. So we saw this problem, and it led to some questions about the research that we wanted to do. So first of all, we ran across an idea called what's called a social trap. It's a type of social dilemma, probably more familiar to most of you as the tragedy of the commons, in which one individual or one group wants a benefit that's going to end up costing everyone else. And while some are tempted to take that benefit, if everyone does, everyone ends up being worse off. So the example here, going back to the joint program context, is that we have a commons, a shared resource of some kind. In this case, it's the development capability of the joint program. And we have these participants, the someone, if you will, who are the stakeholder programs. And we can see that if everyone's tempted to ask for that additional requirement, we can end up with a problem for the entire group. So the way this is summed up is typically as individually optimal decisions lead to collectively inferior solutions. So in terms of research questions, what we wanted to look at was, first, do joint acquisition program stakeholders exhibit the behaviors of a social trap or tragedy of the commons in reality when we look closely at the problem? And can we describe the underlying causal mechanism, okay, behind the observable dynamic behavior, and then do various things to mitigate or eliminate its adverse effects? So we had done some early work in an area called acquisition archetypes. And this came out of the fact that the SEI fairly regularly conducts what are called independent technical assessments, or ITAs, where we go in and take a very close look at a program that's experiencing some challenge. Perhaps it missed a major milestone deadline of some kind. And in these deep dives, we gather a lot of data through in-depth interviews with participants, both at the Joint Program Office and with the contractor and other participants. We review their documents, we will analyze their code, and try and figure out what's going on, how they got into trouble, and what they can do to get themselves out of trouble. And we began to see, over the course of doing quite a number of these, that there were many recurring patterns of behavior that we saw across programs. And we began to represent some of these as what are called causal loop diagrams. You see one on the left-hand side of the slide. And the causal loop diagram is really just a way of showing kind of these interacting feedback loops that really can describe the kind of behaviors we're talking about at a qualitative level. And so we created and then published the acquisition archetypes, a set of them, as a way of describing some of the most significant patterns that we saw. And these are available on the SEI web, and we put out some technical reports and things like that. But we realized that this kind of diagram very quickly becomes unmanageable. It's hard to get your head around just a few of these interacting loops, and even harder when we're talking many that describe the complexity of a fully operating acquisition program, much less a joint program. So we built a model, a system dynamics model. Now, I have spared you the horror of looking at the entire model. This is a higher level view, but I'm still not going to walk through it in much detail. What I'm really going to point out at a high level is just to say that the upper left-hand portion of the model is characterizing the interactions of the stakeholders with the program office and looking at considerations like their willingness to participate in the program, things like schedule pressure because of their need dates, confidence in the JPO to deliver a successful system, pressure to cooperate, and other factors. In the lower right, we see the system development portion where we're really modeling the actual development of the software itself. And here you're looking at some other factors, things like, again, schedule pressure, the complexity of the system, requirements changes in the overall volatility, and how those affect the ability of the program to deliver what it's set out to do. Now, this would be all fine, but all you really have from what I've described so far is still a very qualitative description of what's going on in this program. So to make this model in any way useful or meaningful, we have to base it pretty seriously in data. And so one of the first things we did was to go out and gather historical program data from joint programs that had completed. In one case, we got about 8 years of monthly data on about 125 different performance parameters for the program, which is terrific. So it gives you a wonderful grounding as to what actually happened in terms of mostly the software development. And we also held a set of workshops with different joint programs. So each one only with members of the senior staff who worked on the program in the program office, so they could be giving us basically validation of, do these variables actually connect to each other and do they interact in the ways that we believe we've described. And so we went through the entire model with these sets of folks and to make sure that at least both qualitatively and quantitatively we were replicating the behavior that they had seen in their joint program experience. The thing is, that doesn't give you everything you need. If we go back and look at the system dynamics model, so now we know a lot about the execution of the software development in the lower right, but we have very little information on how, what's driving the behavior, or what is the behavior in the upper left regarding the stakeholder interactions. That's not something we tend to gather when we collect information on the execution performance of programs. So we have another activity going on where we're conducting a scenario-based survey on joint program decision making. And this is actually going out quite shortly to a large number of program offices, with the idea being we want to present a set of scenarios to more senior acquisition staff and ask what kind of decision they would make or how they would react in different situations and what were the factors that influenced them. And so this is the kind of data that's really unavailable through any other kind of mechanism. We're going out initially to over 200 program offices, and we're doing various things to encourage participation because it's an interesting and challenging survey to take. And then we're going to take this data and then feed it back into the model so that upper left-hand segment that we talked about can actually be based on real data as opposed to just our conceptual understanding. And we've worked very closely with Dr. Cody Gonzalez at CMU in the School of Social and Decision Sciences in setting up this survey and designing it. So you put all this together into a model, and looks like I backed up. And what do you get out of it? Well, first of all, you can look at behavior over time. So here are some initial results, mostly from the software development portion of the model, in which we can look at the actual data we got from the program and compare it to the outputs from the model. So we see in the blue line the actual program data, and the red line is the simulation results. So we can look at the source lines of code, current values by month, on the left-hand side, and we can look at the number of development staff required to actually do the software development on the right-hand side. And what we can see is pretty good conformance between both the blue and the red lines. And in both cases, they're really based on the number of requirements that are coming in through to the program that is having to address with software development activities. And so that's one part of the key validation of the model, that we're actually seeing something that truly represents reality. Another type of output we can get that's even more interesting is that, so the behavior over time results, if you will, are something we can run lots of different simulations looking forward, each time varying a different variable and keeping the others constant, and generate what we call a program behavior surface, where we can actually see what do the interactions of, say, two of these variables acting in concert have, what's the effect they have on the overall program. So here we see custom requirements that have been demanded by the stakeholders, so increasing from the left to the right, and we can see the realism of the schedule, which is increasing from the bottom to the top on the right-hand side. We can look at those two together and see their overall effect on developer productivity in the program. And what we see there is kind of interesting, because if you look at this carefully, you'll notice that either effect doesn't necessarily have a very dramatic effect on the overall productivity. In the case of, even as realism of the schedule gets low, we don't see a big drop-off by itself in the productivity. And when we look at the number of customer requirements increasing substantially, we see a significant drop-off, but it's only maybe 30% or so. So still important, but not enormous. But when we combine the two, we see a catastrophic effect on the overall productivity. And essentially what happens when you enter this yellow, orange, and red area is that you've crossed over the tipping point of the program and into an area where essentially the successful outcome of the program is no longer possible at all. And the program is very likely to get canceled because it can't make forward progress at this point. So, being able to visualize this is a really powerful tool, and being able to show someone, here's what you're headed for if you make these different types of decisions. And what we were able to show at a preliminary results is that we really are seeing a social trap or tragedy of the commons at work here affecting joint programs. So then we look at candidate solutions. This is kind of the next thing we would like to be able to do. We now have a model, after we've done all this, of what's going on within the joint program, but we're modeling the problem. How do we go about addressing that, either solving it or mitigating it, at least to some extent? And so here are a couple different approaches that are presented. We've heard from academic literature and also from people, acquisition staff folks we've worked with in the workshops that we've conducted. So a standard technique is to have an authority that regulates the usage of the common good, which in this case is the actual software development resource controlled by the JPO. And the problem is, this is effective, it prevents overuse, but it's very unpopular to enforce a mandate. This is not the most attractive option in general, but it's often the only tool available to us. And as a result, we end up with people finding ways of getting waivers and finding other ways of getting out of the joint program so that they don't have to be controlled by the authority. Now, another approach brought up in the academic literature is what's called altruistic punishment, where you can have different cooperating stakeholders perhaps get together and at some cost to themselves, they can punish their uncooperative partners, the other stakeholders who are maybe making excessive demands on the joint program office as a way of bringing them back into line, hopefully. But there are potential issues with that as well. And of course, there's shared destiny, where we can incentivize people's behavior based on the longer-term outcomes of the program, but that incentive can be pretty far in the future. So each of these has trade-offs, pros and cons, that need to be looked at. So finally, let me just talk a little bit about future applications. We can do acquisition management decision support, where we can use this kind of model to run what-if scenarios on programs in progress and analyze the effects of different decision alternatives. We can create interactive acquisition learning tools, like the one I show here that's for the firefighting acquisition archetype, to help teach acquisition folks about some of these problems beforehand. And ultimately, we can use it to analyze policy and perhaps help reshape how we govern and conduct joint acquisition programs, both at the service and at the OSD level. And so with that, I'll just mention my team: Andy Moore, my co-investigator; Julie Cohen, Matt Collins, Jay Marchetti, and they've done a huge amount of work, and very much indebted to them. And I also hope you'll come by tonight at the reception and see our poster, and we'll have demos of the model and other aspects of the system.